All right, welcome to lesson 5.01. We're going to be graphing and identifying the key features of exponential functions. All right, so an exponential function is pretty simple. An exponential function is a function where the independent or input variable is in the exponent. So let's take a look at a couple of examples. Here's a really simple example. The function f of x is 2 to the x. Okay? Another nice simple example. Make it a little bit different here. So let's say we have 4 times 3 to the x plus 2. Again here we have an exponential function because the independent variable is in the exponent. One more example just for fun here. Y is equal to, and here I'm going to have the base of the exponent be a number less than 1. So I'm going to have 1/3 raised to the x power. That's still an exponential function because the independent variable is in the exponent. What's nice about exponential functions is that we can see that the independent variable controls the number of times that I'm going to multiply the base by itself. Okay? It's exactly what exponents tell us. So there's a couple of terms here, and we're going to get to the general form of an exponential function. But for now, the key term that we need to notice is the base. So the base of our exponential function is exactly that, the base of the exponent. Okay? So here the base is 2, here the base is 3, and here the base is 1/3. And as you can tell, when we have an exponential function, the base is something that we are picking. It's going to be set. It's going to be constant. And so we want to explore what happens when you change the base. How is that going to change the way the graph looks, and what sort of key features can we pull from looking at the base. And then tomorrow we'll take a look at all of the different parameters that we can change and explore how those influence the graph of the function. But for now, we're going to focus on the base. All right, so what we're going to do is we're going to sketch the graph of both these functions, first by filling out the table and then plotting the points. So we have two functions. F of x is 2 to the x, and g of x is 3 to the x. And what we're going to do is we're going to fill out this table. So what I want you to do is actually start at 0 and work through the positive values first, and then go to the negative values and plot each of these points. And I would try to do so in different colors to help you delineate between the two. So first fill out the table, we'll take a look at that together. All right, so let's start with 0. And if we input x, an x value of 0 into our function f, we get 2 to the 0, and that is just going to be 1. Okay? Then we have 2 to the 1, and that is just 2. Then 2 squared, that is 4. And then 2 to the 3rd, that is 8. All right, now let's take a look at the negative values here. And I'm actually going to show my work over here to the right. So let's say I input a value of -1 into my function f. Well, that's going to be 2 raised to the -1 power. I'm actually going to, in class tomorrow, explain a little bit more about why this works. But when I have a negative exponent, remember I move the exponential expression into the denominator and change the exponent to positive. So it'll be 1/2 to the positive 1. 2 to the positive 1 is 2, so it'll be 1/2. So this is going to be 1/2. I can do the same thing with -2. So here I will have 2 to the -2, and that is going to be 1/2 squared. 2 squared is 4, so it'll be 1/4. Okay. All right, go ahead and do the same for g of x. I'll put those answers up so that you can check your work, but make sure you try them on your own so that you're getting good practice here. Okay, so here you can see the values for g of x, and now that we have these points, we can actually plot them. So let me take you through how we might plot a couple of these points, and you can plot the rest. So for f of x here, when x is 0, the y value is 1, so I might plot that point right there. Then when x is 1, the y value is 2. So I'm going to come over here to when x is 1, and the y value will be 2. Might look like that. And so on and so forth. And then once I have all these points plotted, I can sketch a smooth curve that passes through them, and I'll have a sketch of that particular function. So go ahead and do that for both f of x and then also for g of x. And if you want to check your work, you can go to Wolfram Alpha and you can plot both of these functions to make sure that you've sketched them correctly. Once you've done that, go ahead and press play, and I'm going to give you some questions to answer on your own. Remember, our goal is to look at how the change in base is going to affect the graph. All right, so here are the questions you want to answer. You don't actually need to write down the questions. You simply need to label 1, 2, 3, 4, and 5 and write down your responses. And they can be in full sentences, and you can support them by pointing to the graph. So how are the graphs similar? How are they different? What do you think will happen if you change the base of g of x from 3 to 4? What are the end behaviors of the functions? You might recall what end behaviors are. If not, you can go back and remind yourself. And then graph this function below, but before you graph, hypothesize what it will look like based on what we know about the exponents and what we've looked at previously. And then finally, explain how the base will affect the graph of an exponential function. So make sure you take your time with these and really refer back to the graph that you just created to help make sure that your answers make sense, because we're going to build off this tomorrow in class as we continue to look at exponential functions.